which for anyone who doesn't know, I'm sure most people do, but it's a partnership project between Natural England, Natural Resources Wales and the Shropshire Wildlife Trust, with the aim of rehabilitating Fenns and Whixall and Bettisfield Mosses, Britain's third largest lowland raised bog. The project's funded by the EU and the National Heritage Lottery Fund. And the aim of today's webinar is to share the findings of a recent review of 30 odd years of hydrological monitoring data that's been collected. In my experience in conservation, site monitoring is often started, but less often is it maintained for such a continuous period. But Fenns is a bit of an exception, and so I hope you find some of the presentations interesting in that regard. How we're going to run the talk is that during the talks, everyone will be put on mute, but we'd very much welcome any questions or comments, and there's the facility on the bottom right hand side of your screen on the chat to enter in comments, etc. So that would be useful if you could add those there. And at the end, once the two speakers have presented their presentations, there'll be a question and answer session. And for the benefit of anybody who can't make it today, the session today will be recorded, and we can share a link to the recording at a later date. Listening in, I think, is quite I hope is quite a diverse range of people with different connections with the site, including some of our volunteers and staff who've very much been involved in the hard work of collecting all the data that of which we're going to see a sort of analysis. And I think it's just a big thank you to them for all their efforts over decades pulling together all this data. So without further ado, I'll just introduce the two speakers. So we've got Joan Daniels doing an introduction and background to the site. There's no better person than Joan to talk about Fenns and Whixall and to provide this background. She's currently our project officer under the LIFE project, but before that, prior to that, she was, of course, the senior reserve manager between 1991 and 2016, and so was instrumental in a lot of the changes on the site. And she's going to tell us about a lot of the past management. But I'm also really pleased that we've got, after Joan, Sam Leader, Dr. Sam Leader, I believe, who's going to share her findings of a recent review of the hydrological data that's been accumulated over the 30 years. Sam is currently a data scientist at the leading environmental consultancy, Atkins, helping in the sort of, or working for a hydrology and a climate change team. And more recently, she's completed her PhD with Birmingham University in the geography department. So without further ado, I was proposing that we hand over to Joan to take us through the background and context of the work at Fenns and Whixall.
Okay, off we go then. Right. Yes, I just want to provide you with some background to what Sam is going to talk about, telling you about the moss and about some of the hydrological drivers for it. We've been there for 30 years since we displaced the commercial peat cutters. Just for the people who don't know the site, it's it's about a third of the way down Wales on the English-Welsh border. It's 4 miles southwest of Whitchurch and near to Wrexham. You can see the English-Welsh border crossing the site on the right-hand picture. The dashed line on the right-hand picture is the border of the Site of Special Scientific Interest, which is also a special area of conservation, and it's also a Ramsar wetland of international importance. And within that, within this almost 1,000 hectares, there are 2 national nature reserves. The blue one is managed by Shropshire Wildlife Trust, who are now life partners, and the red one has been managed by initially English Nature and the Countryside Council for Wales, now Natural England, on behalf of Natural Resources Wales. To be able to put a bog back together hydrologically, I think it's key to understand how they took it apart. And this huge raised bog was first cut into in medieval times, nibbling around the edge. But the major first inroad into the drainage of the mosses came with the enclosure awards of the late 1700s and the early 1800s, when the big landowners put pipes through the hills that were containing the moss, and they cut in the peat arterial drains. And these drains were specially designed, you can see them at number 1 on the map, they were specially designed to canalise the lag stream, which originally would have run all the way around the edge of the Great Raised Dome, taking mineral-rich water from the surrounding mineral ground and acidic water from the raised bog. And by canalising these drains into the peat, it means they could lower the water table and really set to exploit the moss. Now, fortunately, in 1807, they actually built a canal through 2 miles of Whixall Moss. You can see it, number 2's on the screen. And where they came across an arterial drain, they put a culvert under the canal. Now, the inverts of these culverts set the minimum water level that anyone could drain their bog upstream down to for the next 200 years. So they've saved the moss. And the second thing that saved the moss, ironically, was hand peat cutting. If you look at number 3 on the map, the Lord of the Manor for England let Whixall Moss out to the local men to cut domestically for their own peat, to carry on cutting for their own peat. Now, because of that, they were cutting by hand. When they abandoned an area, the little drains would all block up and the water level would sit in the bottom of the peat cuttings, and the bog species could survive there while Fenn's moss was being commercially devastated. Moving on in time, number 4, they slapped a railway across the bog, which of course was useful for commercial exploitation of the peat. But 5 is interesting. Look at the 2 5s. In the First World War, they put 9 rifle ranges on the moss. They put the drainage in for them. You can see some of the diagonal lines. And the rifle ranges in the foreground were shooting towards the rifle ranges at the background of the picture, the top number 5. The ones in the background were shooting towards the ones in the foreground. And that tells us something interesting about the moss at that time. They didn't kill each other. And that means that the dome was still present during the First World War on Fenn's moss. It was still a raised bog dome. Otherwise, they'd have killed each other. Now, all that changed if you look at number 6, when just after the war, they brought the Dutch in to systematically drain down Fenn's moss. See all the oblongs? They put drains in down the sides of the oblongs and down the centre of the oblongs. And then every 10 metres, they started peat cutting, the little tiny white stripes. And all of these drains are interlinked into the big arterial drains. And of course, Fenn's moss collapsed down, no dome anymore. By the Second World War, the firm had disappeared. The commercial firm had disappeared because coal had replaced peat. So instead, as a bonus, the northeast fens, where number 7 is, we got a bombing range. The whole of the northeast fens was taken over for a bombing range. In the 1950s, compost reared its ugly head for gardening, and a local firm took over the moss. They bought the freehold of Whixall Moss and Bettisfield Moss and the leasehold of Fenn's Moss for next to nothing, because peat was worthless. And they started cutting on the Dutch system. See where the number 8 is? You can see some of the old cuttings there. Same system. And they exported the compost peat along the railway line, the mainline railway. The bog was worthless, so why not plant a whole load of conifer forests around the north end of it, which you can see number 9 there. In the late 80s, the Hanmers, the lord of the manor that owned the Welsh side of the bog, Fenn's Moss, got a lot of death duties. So they raised the commercial rental by a factor of 4, and the local firm backed off, and a great big firm came in from Manchester and started tearing the bog apart to meet the high rental. There was a national outcry to save the site, and the government, meanwhile, had realised how rare peat bogs, raised bogs were. They didn't have enough to meet their international obligations that were in good conditions. So they took on this amazing challenge of mending this devastated bog. And in 1991, we started. Boosted, of course, in 2016 by the Bog Life programme. It was almost total destruction. One drain every 10 metres, Bettisfield moss covered in pine trees, English side of the moss mainly fields, and we even had our own scrapyard. We started with the green bits, and every year we've been buying more and more and more little bits of the moss, doing the jigsaw, 50 more acquisitions. And the nearer we got to the edge, the worse the land we were buying came in. You can see at the top of the photos, pine forests. A lot of it was fields. Quite a lot of it had been drained and abandoned and gone over to woodland or to secondary pine forest. So we cracked on doing the first fix. First of all, cut down the scrub, cut down the scattered trees to stop any further invasion. And if we could dam it, keep on top of what we'd, the scrub that was regenerating on the moss until the bog vegetation had established. And if we couldn't dam it, just keep on top of it until we could. And our men went in with their excavators and dammed up, well, we have one excavator. They went in and dammed up every ditch we could possibly dam up. You can see that it was partially successful. The damming was peat. You can see a peat dam centre bottom, and you can see the wonderful green sphagnum coming back on the right-hand side. Because the moss levels were all over the place, we had to install a lot of stormwater pipes. Otherwise, the moss would just rip itself to pieces. But we were aiming for that water within 10 centimetres of the surface. We managed to land some foot and mouth money that no one else could spend to tackle some of the bigger projects. You can see top left, clearing the pine forest off the 6 metres of black jelly that was Bettisfield moss, using a skyline to drag the trees to the edge. Top right, clearing northeast fens, shallower peat, again manhandling all of the trees to the edge of the bog and taking them away. We have enormous problems with bog scrub regeneration, so we have to limit any nutrient input to the moss. By 2010, we'd acquired enough fields near the edge of the Whixall side to actually tackle a major engineering scheme. The Whixall Manor drain was bringing washing powder and septic tank effluent up onto the peat bog. And is that, can you see the little box? The little box in the top right, Robert, or not? No? Okay.
Yeah.
Right. So we decided that we would divert it back where it should be, nearer the end of the edge of the moss, because it was bringing all that pollution right across the centre of the sack site. This enabled us to put a watershed dam in on the main drain between England and Wales. That kept all of the dirty water on the English side, and it meant that we could put a big weir in at the downstream end of the Fenn's Moss main drain. That let us hold the water in that big arterial drain up to support the dammed peat cuttings on the sides, on the peat cutting flats. And then we eventually, after 25 years of scrimping and saving, managed to land €5 million for our Bog Life project, which has turned into a 6-year project. And this is letting us do a second fix on the hydrology of the moss. The relevant hydrological, let me just get rid of that a minute there. The relevant hydrological actions are firstly to construct a hydrological management plan, and then to secure permission to do the work. And then the important bit is the bits you can see on your screen surrounded in yellow lines, and that was to acquire even more land on the Welsh side, forests, on the English side, excitingly, fields. It should be lag. So we can try and reconstruct some lag vegetation on the edge of the moss. With the forests, section C2 is the stripy dark green stuff, fell the forests, and then light green stripy, fell the woodlands. And then the important bit is this pale blue area, right the way round the outside of the mid-blue area. The mid-blue area is what we've already dammed. The pale blue area is land without any obvious drains to dam. Or, like the big centre-left block, land on a slope where no matter how many times we dammed it, the water just ran through the damaged surface peats down the slope. And this pale blue area was to be using the newly discovered, from Cumbria, the newly discovered linear bunding technique of repacking the surface peats, which I'll talk about a bit later on. The mid-blue area is action C4. When we were restoring the moss, damming it, we dammed each oblong, each peat cutting flat individually because of the mess of levels the peat cutters left. And the Bog Life project is to marry all of those together. So we lose some of the trackways, but we'll have bigger hydrological units there. We also have problems with pollution. And if you thought that that scrapyard in the bottom right-hand corner is filthy enough, even though we've taken the tyres and the scrap off it and we've covered the asbestos in it, then from the bog's point of view, just think about the nitrogen pollution falling out of the air onto it and every other SSSI more or less in England. Action D is to monitor the effects of what we were doing. What are the hydrological drivers for the moss? Obviously, it's setting, the geomorphology. The moss runs from southwest to northeast on its southeastern side, the white area on the right-hand map, we've got a clay moraine. On the northwest side, the white and the dark green stripy stuff, that is a sand moraine. And in between the two of them, we have a glacial outwash sand plain. Not a valley, a plain. And on that plain sits a peat bog. What's a peat bog doing sitting on sand? And the answer is in the bottom left corner. There you can see that the water tables, when the glaciers were melting, must have been high enough to create a lake. And the lake clay has sealed the sand. So over thousands of years later, when the water tables generally dried as the climate warmed, bog plants, fen plants, swamp plants could persist there and build up as a dome, which then blocked the valley, preventing any water running down it, wetting up the sand to the northeast, and the bog was able to spread northeastwards by terrestrialization rather than the hydroseral succession in the lake. Incidentally, this map shows some of the arterial drains. Particularly look at the northwesterly most one, the Bronnington Manor drain. It runs all the way down right the way down the western side of the bog and down to Wem. So other hydrological drivers are the peat integrity and the topography that you're left with. We were left with 5 different peat cutting types. Tiny residual areas of uncut peat, the yellow bits. Some so badly damaged, like the picture in the bottom corner, Bettisfield moss, completely covered in self-sown pines. The blue bits and the green bits, not too bad. They're the old commercial cuttings where the bogs persisted in the bottom of the cuttings, but the bulk of the surface was dry heath or forest. And the red bit is an interesting bit in the middle. When I came, it was a desert, the top left picture. Just row upon row of stacked peat, ditches, drains deeper than your head, not a drop of water in sight on this important raised bog. Now fix your eyes on the red bit, because this is Richard Lindsay's impenetrable isometric view of the peat surface of that red bit, the commercial cutting that he did when we were trying to acquire the bog. Dense colour means low areas. You can see our raised bog dome has a big saucer cut in the middle of it. We haven't got a raised bog topography anymore, and this is critical. Every single oblong is at a different level, and so you've got to be very careful when you're blocking it up. Richard also gathered loads of peat depths, a lot of the depths in the middle. We've been adding to them since as we've acquired land, because peat depth is another hydrological driver. But water quantity principally depends on climate. We're in the Welsh rain shadow. You can see how little rain we get, 750 mil for most of the time. When I started, the average was 625 mil for 10-year average. It's gone up a bit with climate change, but look at the 30-year variation. When I started in 1991, we got 495 mil. 2 years ago, we got twice that. We either get not enough or too much. We go from drought to flood. And it's important, the peat depth interacting with that, especially in these summer droughts we get, because the shallower peat leaks into the sand. Obviously, the deeper peats are in the southwest, where the bog began to form, 6 metres on Wem moss, Cadney moss, Bettisfield moss, 4 to 5 metres in the centre of Fenns and Whixall moss, and then 3 metres on average in the rest of Fenns moss, growing to the yellow line, which is the boundary, the 30 centimetres of peat. We're lucky. This isn't the Fens where the peat goes on forever and ever and you're trying to manage water in the middle of everybody else's water. We've got quite a well-defined blob of peat left. Obviously, another hydrological driver is the vegetation. We know our pine trees intercept 30% of the water before it even gets to the ground, and then evaporation from those, the birch and the heather, takes another chunk out of our rainfall. So the minute we get a forest, we fell it. We've got to be very careful though, because we have to mend the bog after the timber fellers have been in. So if we can skyline or control where the brush tracks are put, it means that we can get to the ditches and control any regrowth and wet the bog up afterwards. Another driver for us is the permeable peat surface. The damage caused by the drainage means that for at least 50 centimetres, water can just run through the surface peat. So no matter how you dam it up, if it's at all on a slope, the water's going to run out of it. So we were very lucky that they'd invented this new technique of damming where you dig up the top metre of peat and smash it back into the ground and leave little buns above the ground of claggy, smashed up peat, which you then cover, as you can see in the picture, with surface vegetation to stop them cracking. And you can see the royal blue on the picture, which was the original bunding plan. You can see some of the cells in it. You can see the maroon colours, which are additional areas that Dinsdale Moorland Services have bunded or dammed for us. So we're encircling the white bit in the middle, which is our first fix of dams. Now, Sam is going to talk about two areas. One of them is on Fens and Whixall, which is predominantly the first fix damming. The second is on Bettisfield Moss, that purple, star in the purple near 18. And there we've cell-bunded the hand cuts and we've put contour buns around the edge of the that uncut dome. Another hydrological driver is water quality. Now, over the years, we've tackled some of the pollution, you know, the washing powder from the moss cottages, pig slurry from Wen Moss, the wildlife just stopped that, and we chopped down the forests. But in the restored bog, we've got to be very careful because big pools attract birds, and then we get far too high pH in the water for sphagnum to grow, to mend the bog. We also have upwellings with mineral water coming out of the sand underneath the bog, and I've already mentioned the astronomically high critical nitrogen load coming from agriculture around the bog, which is encouraging Molinia and birch. And also the mineral water coming in from the lag streams. So one of our latest ventures has been to put the Bronnington Manor drain back to the edge of the bog. If we could, to avoid digging a big sandy channel that'll drain the edge, we've put it culverted through pipes across the peat bog, like you can see in the bottom right picture. Otherwise, we've had to dig a new channel, which will allow us to dam the old channel. And this lets us bund, as you can see in the bottom left, the peat that is to the north side of that drain. And already the winter storms have done us proud, filling it up. Now on to salmon monitoring. My kind of monitoring is, first you see a peat cutting, a forest cleared desert. So you've got nothing, you've got desert, and then you cell bund it and you take a picture and Bob's your uncle paddy fields. But when we started, I knew about climate change. I knew that raising water levels when a community has spent 500 years draining a peat bog was going to be controversial. So we put in a lot of hydrological monitoring, putting 3/8-inch gas pipes down right to the bottom of the peat so they don't ride up and down in the peat. And once a month, the volunteers go out to these 130 odd dip wells and measure how deep below the peat surface the water is. We also have some constant water level recorders, more so with the life money we've got. We put in lysimeters and evaporation pans. Olivia Bragg helped us with that. And because we knew we were going to fettle on with the main drains, we put in some crest gauges which measure the variation in water level up and down in the main drain. And here is the Dipwell cross on Fenn's and Whixall Moss that Sam will be talking about, and on Bettisfield Moss, the Dipwell transects that cover all sorts of different bits of the cuttings and the intact ground.
Yeah, thank you all for taking your time out today to join this presentation, and thank you as well to Natural England for asking me to present. I'm Sam Leader. I'm a hydroecologist and data scientist and in the water management consultancy at Atkins. Last year I was tasked with conducting the analysis of the 30 years of hydrological data at Fenns and Whixall and Bettisfield Moss. And it was really exciting to be involved in this project with such a brilliant monitoring record. So today I'll be talking for about 30 minutes, outlining some of the key findings from this analysis and understanding how management of the mosses has impacted on water tables and flow. So can I just check you're seeing my screen in slideshow view and not presenters view as well?
Yeah, that's fine.
Okay, great. Thank you very much. Okay, so today's presentation broadly presents the finding in a report that I've written, which I believe Sophie at Natural England has circulated. So all the finer details on methodology as well as the more detailed statistical reporting are in there. However, there'll be an opportunity then to ask questions at the end, some discussion too, or there is the chat box on the bottom right if you want to ask questions as we go along. So to quickly go over today's content, I'll be introducing the project aims at March's Mosses bug life and the specific aims that are of interest to this piece of analysis. I'll also quickly recap management. Joan's done a great job of that, so I won't dwell on that for too long. And then before diving into the analysis, I'll also outline the data that's going to be discussed. Then on to the really super interesting findings. I'll be explaining the changes in water levels and then follow up with some changes to flow. I'll also then explain how that relates to management, and for that purpose I'll also be untangling the interactions with climate as well. And then we'll finish up with that time for questions and discussion. So there's quite a few aims of the March's Mosses Bog Life project around improving hydrology, water quality, ecology and habitat. The main aim of interest for this piece of hydrological analysis is to restore lowland raised bog by raising water levels. And this is achieved through all those methods Joan's just shown, removing woodland, bunding, piling and damming the drainage ditches. The key objective for evaluating the performance of this restoration and hydrological conditions is to raise water levels to within 10 centimetres above or below the ground surface. This is a key theme for today's presentation, so you'll hear me refer to this a lot as target water levels or target water conditions. So these target water conditions are set because they're really important for promoting this kind of habitat. It's where specialist bog vegetation such as sphagnum mosses can form, and then they further maintain those saturated conditions and peat formation. And then retaining this near surface water table is also really important for keeping that carbon locked into the ground as well, whereas under dry conditions carbon can be emitted from these peat bogs. And you can see from the pictures on the right, Joan's shown some more that were really brilliant. You can see the top picture is an example of the dry damaged bog, where later on the bottom picture you can see water tables have come up right to the surface, and these are more like restored water levels. So in order to review hydrological conditions, so I've done some extensive visualization because there are a lot of wells across the site. There's 182, I think, that came to me in the analysis. It's really important to examine changes not just in the long-term trends, such as looking at mean summer conditions over 30 years, but also look at how the water levels change seasonally and that within-year pattern and how that's modified. So time within target conditions, that plus minus 10 centimetres is another really important variable, as it reflects system stability, and it also tells a much fuller story of than averaging across a whole year or just selecting one time point in a year. And then finally, I've also analysed some discharge at the mosses and associated the runoff coefficients to understand how management has modified flow retention at the mosses. So Joan's just done a great overview of the management. So I'll go through this quite quickly here. The key areas of interest are the bunding that was installed in 2017 onwards. So that is shown by the purple and pink bund nets we can see here. And further to that as well, we've got the damming that was implemented through the 1990s in Fenn and Whixall. All the data points that you're seeing, so these blue points, grey points, they're all the dip well locations. And further to that, we've also got 10 automated level loggers and 2 weirs as well that are located near this gauge here as well. And this is a more timeline-focused look at that management history. So in these plots, along the x-axis, we've got years starting from 1989 going right up to 2020. And on the y-axis, that's the individual dip wells that you saw on the map. So the left plot is Bettisfield, and on the right, we've got railway and canal transects of Fenn and Whixall. So if we start with Bettisfield, you can see in 2001, we had tree clearance that affected all of the dip wells site-wide, so all the dip wells would have caught that impact of that, followed then by 3 periods of damming in 2003, 2008 and 2011 that affected different parts of Bettisfield Moss. And then the implementation of that bunding, which happened in 2017-18 onwards, which again affected the whole of that site. For the railway transects and canal transects of Fenn and Whixall, it's much more sporadic in that damming had more localised effects on certain dip wells, occurring right through the 1990s, and then bunding, which was on the periphery of Fenn and Whixall, so it isn't directly located next to all of the dip wells. So hydrological data has been recorded and monitored at the mosses by Natural England volunteers and Shropshire Wildlife Trust volunteers since 1993. So this is an amazing unparalleled data set in the UK. It's really high value for wetland habitat monitoring and management and research as well. I think internationally it could have a huge impact. The breadth and frequency of monitoring enables a really good analysis of the management practices and how the environment has changed, because we can compare both prior to and post management, and also that there's recording of unmanaged sites alongside managed sites. You can do statistical analysis comparing those and have greater confidence in the results, relating that to the management that's been implemented. So in total, there are 182 dip wells across all the transects. The graphs on the right are a time series showing the mean of each transect. So that black line is the mean of a particular transect, whereas the grey ribbon and the blue ribbon are the standard deviation or the maximum minimum of that transect. So combining all of those dip wells. So it really shows the huge spatial variability in these mosses as well. The data set's then complemented with the high frequency 10 automated level loggers, and then there's also the 2 weirs that have been monitored on approximately a monthly basis since 2013, and crest gauges as well. Okay, so now I've talked you through the background to the hydrological monitoring. This is Bettisfield, a closer look. So this is the map on the left with the bunding nets. And what I've done is I've classified the dip wells into 4 groups based on their management history. So going from left to right, we've got dip wells that were bunded in 2018-19, following some damming in 2011. The lighter blue is dip wells that were bunded in the later period, 2018-19, and dammed in 2008. And then of the 2 grey groups, we've got those both bunded in 2017, but dammed in 2008 or 2003. And what we've got on the right-hand side, I'm presenting a time series of the annual average of water level, and also approximately a monthly basis as well. I'm also presenting these dotted lines, which show that target plus minus 10 centimetres. So if the water levels are above 0, which is the ground surface, that's standing water, and these are levels below the ground. The first thing I really wanted to point out here is the seasonal pattern. So the water table drops anything between 10 and 40 centimetres every summer as the conditions get drier. So winter conditions are generally within that target range of plus minus 10 centimetres, but it is drying out below those target conditions each year. The interesting thing to see here is that the seasonal variation and summer decline doesn't happen in 2019, and actually the water levels continue to wet up through that period. It would be really interesting to see if then it is stabilised here. We can see that we're actually seeing for the first time conditions that are getting too wet, so they're going above that 10 centimetres above the surface. Oh, excuse me. The other really interesting point here is if we look at the annual averaging graph and we look at 2018, the 2 sites, the 2 blue lines that were bunded in the later year, show a drying trend in 2018, whereas the 2 management groups that were bunded earlier and in 2017, they show a wetting response in 2018, which was a dry year. And then all sites have wet up in 2019. The greatest increases in 2019 are about 18 centimetres, which is 50% more than the range in water levels seen between 2003 and 2018. And it's 140% more than any single year increase. So these are significantly large increases in the water table. So this slide is to demonstrate how the proportions of within target water conditions have changed. So these are time series stacked line graphs. So grey is dry conditions, they're more than 10 centimetres below the ground. The light blue is within target conditions, and the dark blue, the navy, is conditions that are wetter than target conditions. And so what you can see is for 3 of those management groups, they are too dry, they're drier than target conditions for more than half of the time of the year. And also for the summer as well, so between May and September, so that's those bottom graphs, the dry conditions take up a large proportion of the year. We then see the increases in 2018 and 2019. So the proportion of grey area drops considerably, but we also start to see an increase in conditions that are wetter than target. So another interesting fact here then is that actually some of the sites didn't see an improvement of within target conditions, because they actually, whilst they decreased the amount of time they were too dry, they are now showing a lot of standing water and have exceeded that target condition. It would be really interesting now to see if in 2020, 2021, if it's stabilised into within target conditions, or it has maintained that very wet state, because 2019 was a wet year as well. So this map is presenting the within target statistics shown on the previous slide. The background colour indicates whether it's been scored as dry, wet, or within target. So if it's grey, On the scale, that means it's dry 100% of the time of the year, whereas the dark blue would be sites that are wet 100% of the year. And if it's turquoise, that's the sweet spot, that's within target range. This is based on a spatial interpolation, so it's not a fully modelled representation of how water levels vary spatially, but it does paint a really clear picture of the changing conditions. So you can see in the top maps in 2016, 2017 and 2018, they're all majority grey. They're drier than target conditions for a large proportion of the year. We do see that improvement in the east side of Bettisfield in 2018, where the bunding was first installed. And then in 2019, we see that the majority of the map is this turquoise colour within target conditions. And we actually now see that the sites bunded in 2017, so that's these sites on the east, have now become wetter than target conditions for a large proportion of the year too. Okay, so now moving on to Fenn and Whixall, which is the canal and railway transects. I also identified a number of management groups here based on the damming timelines. To keep things simple, I've just selected 3 groups for this presentation, but analysis of all the groups and also all the individual dip wells is within the report and appendices. So on the left, I'm showing you a time series again on roughly a weekly, monthly basis since 1993. And each line is an individual dip well. And the dotted lines again represent those target conditions. Again, we see the drops in the summer water tables each year. And you can see some of these wells are generally having an upward trend from the early 1990s. And then on the right side of this, the right-hand side graphs, the data is then expressed as a percentage drier than target. So if it's a value of 100, it's drier than target 100% of the time, which is the case for a couple of these dip wells for the entire time series. But we also see some dip wells that show a considerable drop-off in the 1990s. So they're now within target for a large proportion of the time. But there are also some dip wells that show a return or fluctuate back towards dry state as well. So there is a real complex and spatially variable response here at different points. This map works in the same way as the previous Bettisfield map I showed a couple of slides back. So the colours indicate of the background where the water levels are wetter or drier than target conditions. Here we're not seeing a huge difference in 2019 compared to previous recent years in association with the bunding, as that was still ongoing, or it's not in close proximity, it's around the peripheries. What we do see here is that step change in the 1990s following damming on the mosses. So if you see on the top left, 1995, most of the mosses is drier than target 100% of the time. So the whole year was drier than that target condition. But in 1999, we see a high proportion of within target conditions and also some wet conditions too. And it seems to have stabilised from this point onwards. To complement the dip wells, we also have the automated level loggers, which were at 10 locations around the mosses. So S18 here is the autologger situated on Bettisfield. And we'll take this one as an example. So this is plotted across day of the year, and each year is presented as a colour. So 2018, which is this grey colour, you can see throughout the summer the water level just completely drops off and starts to wet back up as it goes into winter again. Whereas in 2019, we're not seeing that drop off in the summer. It maintains that water level for the whole year with fluctuation with rainfall events. And that seems to be a recurring pattern in all of the autologgers. We're also seeing 2020 coming in after 2019, a much higher water level. So this was the data I had available at the time, so we can see the start of the year is quite wet. So what I've then done is a comparison between 2018 and 19, just to understand how management has impacted water levels seasonally. What is the difference in the winter impact and the summer impact? And mean July water levels have increased anything between 27 and 83 centimetres. And that's compared to an increase of 2.7 to 40 centimetres in December, which is really good that it's improved those summer conditions, which were dry, but hasn't significantly impacted those winter conditions that were already within target. So that means we're not going to get too much flooding in the winter. The water levels haven't also increased by the same proportion.
Has left the meeting.
So I've now mentioned a few times that 2019 was a wet year. So obviously that becomes the question, was it climate that drove the changes, or how much of it can actually be explained by management? So this is a conceptual diagram just to talk you through the analysis I'm going to present to understand the climate interaction. And this is a scatter graph of annual precipitation against mean annual water level, which produces a linear relationship whereby a wetter climate results in a higher water table. We then fit a regression line through these points and use the associated equation. So with that equation, we can then estimate what water level you would expect for a given amount of precipitation. So for this amount of precipitation, this would be the water level you'd expect. But in this case, our post-management year fits much higher than that expected line, and we can then actually look at the difference between the observed and expected and say, for this amount of rainfall received in this year, it is so many centimetres wetter than we expected. There are some sites that won't have a strong climate water level relationship. That could be due to surface flows or some other kind of interaction, and those have been flagged and excluded from the analysis. So these are those 4 management groups from Bettisfield, and we can see that, so because we've took the average across each management group, these don't have amazing relationships, but on a site-by-site, dip well by dip well basis, there's some real strong relationships between precipitation and water table depth. But the message still remains here that 2019 does fit considerably higher than we expect for the amount of rainfall. So despite it being a wet year, there is a huge difference in that water table, and it doesn't fit anywhere near to that regression line. And that is consistent across all of those management groups as well. So what I've then done is completed this analysis for each individual dip well. And I'm presenting 2 maps here, the left being just the water levels. Where is the water level relative to the surface? And that's on the left. So if it's grey, it's below the surface. If it's turquoise, it's within that plus minus 10 centimetres. And if it's a dark blue, it's standing water. But going back to that observed versus expected water levels, every single dip well was showing wetter than expected conditions for the rainfall in 2019. And what we actually have is the dip wells that were affected by the earlier bunding have got the greatest changes, and they're up to 35 centimetres wetter than expected. Right the way through to up to 5 centimetres for some dip wells. The ones with crosses through are ones that didn't have a significantly strong relationship with climate. But even so, we're still seeing a really good pattern across the mosses that mirrors the water table depths that we're seeing as well. I repeated this for Fenn's and Whixall's railway and canal transect 2, and that was conducted for every single individual dip well. This tells a different story because the main impact on water levels here was the damming in the 1990s. So rather than highlighting 2019 out, actually it's these, so the colours just represent the year, so it slides from yellows in the 90s through to dark blue recently. So these are those 1990s years, which you can see on a completely different relationship with climate. They're considerably drier. So there is a step change in the response to climate post-damming, which seems to have had a huge impact across lots of the site. Okay, so moving on to flow now. So water flow at the Mosses has been monitored on approximately a monthly basis at the upper and the lower weir since February 2013. And flow peaks over the winter months. So the graphs I'm showing you, they run from July to July, and each line represents a different year. So we can see that winter peak happening. And what we actually see is throughout the years, the winter peak is becoming much reduced and is later on in the year as well. So that winter peak is much more delayed and much more reduced, especially in 2018-19. Maximum flow was observed in January 2016 at 0.26 metres per second. Compared that to 2019, the peak flow actually happened in March, considerably later, and was only 0.07 metres per second. So this indicates that there's greater retention of flow from winter precipitation within the Mosses. This has then been converted into a runoff coefficient. I did just see a question pop up as well, so I will address that now, of how the flow was, I think it was measured or calculated, and that was with a Kingsvater equation where the height above base was then converted into a flow. The runoff coefficient was then linear interpolated into daily time steps in total for the year. The accuracy of this approach was estimated on daily flow by correlating it with the daily level logger locally, which showed a really significant positive correlation. But there are periods where there are poor correlation because obviously we're monitoring flow on a monthly basis, and that didn't always capture all the high rainfall events. So for that reason, there is greater confidence here in the monthly runoff coefficients. But there is still a lot of confidence as well in those annual numbers too. So there's a decreasing annual trend of runoff coefficient. So that means that the amount of rainfall that ran off and left the catchment has been decreasing. And this means that a large proportion of that rainfall is now being retained within the Mosses. And then on a monthly basis, the runoff coefficient has decreased from nearly 50% in February of 2015 to just 20% in February of 2019 at the higher weir, which echoes again that the previous slide of the reduced flow. Okay, so just a quick roundup. The reduced flow, the runoff coefficients, and the higher water tables, really the take-home messages that then indicates there's a greater retention of flow within the Mosses following management. Bettisfield water levels, in 2019, the levels are significantly higher than previous years. They're up to 35 centimetres wetter than expected for the rainfall in that year. And the proportion of dry conditions was greatly reduced compared to previous years. Fenn and Whixall has got a much more diverse and complex response spatially. There's some evidence of improvement following bunding in 2019, but the clear message here was that damming significantly changed the response to climate prior and to post damming. Flow, also the decreasing runoff trend and the flow peaks occurring later in the year really do signify that there is greater flow retention within the Mosses. So yeah, it looks like the management has had a huge impact on the hydrology at Fenn, Whixall and Bettisfield Moss. That concludes my presentation for today, and thank you all for listening.
Thank you, Sam. That was really great. I love the way that you were able to bring to life some very dry statistical data using visualizations and maps. Certainly helped me grasp some of the key points that came out of your analysis. So now there is the opportunity to ask any questions. There's not much coming up on the chat, but there is the opportunity to ask questions to Joan and Sam.
Could I just make one point before people ask questions about the Bettisfield to Fenn's data difference? Just to make the point that, it's Joan here, just to make the point that the damming at Bettisfield was not the same as the damming on Fenns and Whixall. On Fenns and Whixall, we had one drain, one peat cutting every 10 metres. The earlier damming at Bettisfield, there aren't any drains there apart from down the few trackways across, like up the English-Welsh border. So we were unable to do much damming at all. So the effect that Sam's picked up is very much the bunding. Thank you.
Sophie, can you unmute everyone? And then people can ask questions directly. Thank you. Yeah, so it's an open floor, really. Has anyone got any questions or comments that they'd like to offer, or observations?
So this is Max. Can you hear me?
Yeah, thanks, Max.
That was absolutely awesome from Joan and Sam Leader. Congratulations to everybody, in fact, the whole team. I have a question, just a bit of clarification for me, really. Point I didn't quite understand on the Whixall Canal Transect. Sam, you said that it showed an improved response to climate after the damming in the 90s. Do you mean that that the water levels actually responded better to higher precipitation events than they would have done prior to damming? Could you just clarify sort of what you meant there?
Yeah, of course. Thank you, Mags. So really, it's just the following the damming, the water tables were higher. So there is a step change response. So I haven't in detail gone into the rate of change in response to climate, but what we're seeing is that for the same range of climatic conditions, the water table is sitting at a much higher level. So damming has retained that flow and raised the water tables.
Okay, thank you.
Yeah, can I just make the point, it's Joan again. One of the things that is pretty obvious from Sam's analysis is the high impact of topography on the location of the actual dip well. You were talking about the canal, Mags, down by the canal there are some very low areas, and once we block the outflowing ditches by damming, then the water has to pool up there because it can't get out. The ones that looked very dry on Sam's analysis, like X10, up on the railway line, so they're on higher ground where the water can flow out, and that's why we've just spent some extra bunding money to bund along that slope to try and hold the water up there. So it very much depends on the topography as to what you get, which I'm sure our hydro monitors will back up.
Yeah, thank you, Joan. I do have another question, but I'll pause because someone else might have one too.
Ian, I notice you've just added a question. Do you want to ask your question?
I can. Yep. Yeah, thanks. That was great. Really, really good. I think I kind of partly know the answer to this, but I just wondered if you could elaborate a bit. I mean, obviously we've got a good time series now of water table, which is clearly critical, but what we hope now is that the vegetation will respond in the way that we want it to. So do we have monitoring, or have you done your quadrats? Are we confident that they'll link closely to your dip well locations and measured water tables, so we can make a really strong linkage between change in vegetation and water.
Do you want to tackle that one, Joan?
Yeah, we've a lot of our monitoring, as you know, has been done by our wonderful volunteers and students. And we've had quite a few studies in the past, like after we took the pine forest off Bettisfield, where we've monitored the vegetation in quadrats and the long-term monitoring quadrats on the main moss, and we've actually got dip wells next to them. So there have been studies which have actually correlated quadrat with exact water table at that point. And we've had this done in bits and dabs over the year. But Sophie might like to say a bit more about the long-term monitoring network.
Yeah, so we've got the long-term monitoring network on site, which has 51 quadrats over all the mosses, including WEM, and each one of those has a dip well next to it. They were monitored regularly when they were first put in, but just lately they've only been monitored sort of peak and low season to try and get the higher and low tables, so only once every 6 months-ish. But there is the potential to do more monitoring when the vegetation surveys are done recently. We do also have other vegetation data which is done for the LIFE project, and even though it's not linked directly to a dip well, it is in the different areas where the work is being carried out. So hopefully that should show changes in vegetation type compared to the different monitoring methods. So yeah, we do have data that should hopefully show that.
Have you been able to kind of collate it in the same way that we've done here? Is it ready to present, or is that the next in the series?
Oh yeah, it's not ready to present yet. Not all the bunding is still continuing, so management is still ongoing. So all the baseline survey has been done, but we haven't done the second lot, so we only have a baseline at the moment.
Okay, great, thank you.
Richard Lindsay here, sort of follows on from the discussion that's just been happening, but it also, my comment also relates to the whole hydrological monitoring program, which has been really good, and it's shown some excellent results. Going forward, I think we'll need to start incorporating another factor in the monitoring program. And that's because when you have a peatland with a sphagnum carpet, you actually have two hydrological systems. There's the water table behavior in the peat, but then the sphagnum carpet itself can actually operate almost independently from the water table. In fact, it can operate entirely independently from the water table. Andy Baird won't let me describe it as the sphagnum water table, but in effect, that's what it is. So I think what we've seen in the analysis of the hydrological data up to now is the behavior of the water table in effect in the catterton. But as we get more sphagnum being established across the peat surface, we will find that the hydrological response changes, and we were just seeing kind of indications of that in the way that the correlations were beginning to change. The point about sphagnum is that it doesn't have a cuticle. So it's able to absorb moisture from the air very easily. When the cells are empty, they actually create a huge suction pressure. So any moisture is immediately drawn into the plant. So What we really need to be looking at going into the future is occult precipitation, hidden precipitation. So that's mist, fog, dew, all of these periods of high atmospheric moisture that don't appear in rainfall records. So you can have a rainfall record that shows a month without rainfall, and yet every night the sphagnum is being rewet because of dew or early morning mists. And that's an absolutely crucial factor, because it means that sphagnum can persist in what are, to all intents and purposes, apparently, according to rainfall gauges, periods of extreme drought. And yet the sphagnum is being rewet perfectly successfully every day or every night. And so what that does is it creates a surface layer which is of which has a very high moisture level, but the water table in the peat beneath it can be even 30 centimeters below that layer. The system will finally become more natural when those two layers combine. So what we really need to be thinking about is, how do we measure occult precipitation as we go forward in terms of our monitoring systems? And the whole valley that Fenn and Whixall Mosses lies in, I'm sure Joan can confirm, will be prone to, for example, early morning mists.
No.
Really significant factor.
No, we don't have mist, Richard.
Really? You don't
No
have
mist.
early morning dew?
We have dew.
Oh, well, there you go.
Can I just add something? Sorry, it's David Gasker here from Atkins. I think the point Richard makes is actually very, very important. I think whilst I guess lots of us here, we're really interested in the wetland management side of things, I think from a sort of landscape scale restoration perspective, possibly the most interesting data that Sam certainly has shown is regarding the outflow and how the runoff coefficient has changed. So what that is telling us is, I actually love the concept of occult precipitation, by the way, Richard. I think that's just absolutely marvellous, and I'll be using that again at another time. But I think what it shows is that as you restore these peat-based habitats, and as that sphagnum sponge activates itself, we can actually see the effect that has on the amount of water that is running off from the landscape as a whole. And to me, in the sort of current, direction of travel that we're all in around sort of natural capital and ecosystem services, this is possibly one of the best data sets I've certainly seen that starts to tease out the magnitude of changes that you expect when you restore wetlands, which is, I guess, what a lot of us here are interested in. So that was just one thing I wanted to say. I think the second thing is, I will say, is to all of you who are out there monitoring and running this project, please don't stop. Keep going. This is absolutely an incredible data set. And I think if we weren't also focused on this sort of, local activity, if you shared this on any of the sort of global conferences that some of us get to go to now and again, people would be blown away by the duration and intensity of the monitoring that you guys are all doing here. And it's just to finish off on my sort of diatribe here, I would really love to just hear from some of those of you, the volunteers who are actually out there doing this monitoring, just to understand what's the motivation for you? What do you get out of it? Because, if we are going to, somebody, I think Pete Jones was saying, wouldn't it be great if we had a national network of peatland NNRs monitored like this? It's not going to happen unless we engage local communities. And there's a big movement around citizen science right now. And you guys are real pioneers on this. And I just like to understand a bit more about that. if at all possible. But yeah, just amazing data set, guys. So thank you.
Can I make a comment on David, just on David's first point? We've got to be very careful when you're interpreting any of this data, the flow data in particular, to understand what you're actually looking at, because the amount of water flowing off has become less. And that's probably because you're looking at the Fenn's Moss main drain, and a lot of its water comes, or a good third of its water comes from the northeast Fenns Moss. And we have done, in the timescale Sam was talking about, we've done a lot of bunding upon the northeast Fenns Moss. So that will have held and deprived the Fenns Moss main drain of some of the water that would have otherwise been running over those weirs. And the interesting thing is going to be, which tallies in with David's second point, that it'll be interesting to see what happens when the bunded ground is wetted up properly, because it probably take 5 years for the peat to absorb the water back into it, as to whether we'll find the flows going up at the weir after that, because you'll have actual more runoff. So it's early days.
Can I just invite, Roger, can I invite you to ask your questions that you posed on the chat? And also, as a representative of a volunteer, you might want to answer Dave's point.
Okay, thanks, Robert. Yeah, excellent presentation. It was great to see the correlation between rainfall, the runoff, and clearly the bunding work that's been going on. That's fascinating analysis, and clearly this is the start of a longer term review, I suggest, around what's happening over the longer term, particularly on Fenns Moss, where we're not quite there yet in terms of getting the data that we need. My questions were, first of all, around water quality, because clearly this is water level is part of the picture, but water quality is also another part of the picture as to what science we're getting out of the water quality measurement to achieve the better growth and spiking that we're looking for. The second question is, is there any need for changes in dip well locations? We've had these dip wells in the same places for a long time, and in terms of science, that's great, but should we be reconsidering any part of that positioning and layout of the dip wells? And I suppose the other question is, as I mentioned earlier, about repeating the process. How often are we going to do that, and what's the plan around that? In response to the question about why do we do this dip well monitoring as volunteers, it's actually a very nice walk out, but it used to be a nice walk out. And you see lots of nice nature and interesting wildlife and such like. And I think the truth is that it's actually getting wetter and wetter as we do it. So you have to be more and more careful as you do it. And I do now most of the data input. So I sit at a PC and key in all the numbers, which is fine, but it's quite a laborious process sometimes. But as long as the data is being used, then it's well worth doing it. Thank you.
Thank you, Roger.
On the water, do you want an answer on the water quality side?
Yes, please. Yeah.
Yeah. We've depended, as always, because we've been skint up to the LIFE project, on student projects to do this. And we've had some right from the very beginning, when we wanted to know more about the washing powder and the septic tank effluent going up onto the middle of the moss, to give us a justification for land acquisition and moving the drains. We've been doing pH and conductivity surveys, usually of the arterial drains. And this is where my alarm has been coming, because we've been able to obviously tackle some of the water quality going up onto the moss by diverting the Whixall Manor drain to the edge, for example, and same with the Bronnington Manor drain. But it's the what I'd call those hidden factors, the that are actually, when I look at recent pH surveys and conductivity surveys, they're showing that the pollution's spreading. It's actually spreading because we're getting more bird pollution in the pools, and this comes back to the way that you mend the moss, because if we'd looked for the highest point and said, right, we're going to rewet those 6 or 7 flats by damming that highest point, we'd have made a great big lake, and we'd have had 2,000 million birds, loads of dropping, and not a shred of bog moss. And I think you're really spot on there, Roger, with how we need to think about the how we go forward with marrying up all the dammed areas in the middle of the moss with a sensitive bunding that isn't going to give us lakes.
Can I ask Sam to have a go at the second question about the current layout of dip wells? I don't know if you feel able to comment on that, whether it's still relevant,
Yeah, of
whether
course.
we should augment them in some way.
Yeah, I think I'll partner that with Mags's question as well about the efficiencies in the current monitoring programme as well. So from a statistical point of view, the more sites gives more confidence in the results. In terms of strategic layout, I can only speak for the sites that are there. And I think people like yourself, Roger, that are there visiting the site frequently, you might notice there are parts of the mosses that are changing that we're not capturing. And so you actually have a lot of valuable data just in your observations, and the same for generally any volunteers or visitors to the mosses. There's a wealth of information to be tapped into there. So that might be possible that there's some observations that could be shared there and some recommendations that actually come from volunteers and visitors on that front. In terms of efficiencies, so I group together dip wells with similar management, which is great for then these kinds of meetings and discussions where we can actually associate changes with management strategies. It's possible there are some redundant wells, but if it depends. If it's not too much time to just go and get some extra data points, I'd really recommend that be maintained, and because this data set really is a really valuable data set. But I would go back to my point of if the layout needs to be changed to the dip wells, I think some feedback from people such as yourself, or maybe some kind of photographic monitoring, would help with that in going forward. The third question you posed was about when will the analysis be repeated? So I know there's been some ongoing monitoring despite the pandemic. I don't think it has been as frequent, but there's still going to be a really valuable data set there. And I worked together with Natural England to produce some R scripts. So this is some code that reproduces this analysis. So as long as the database is still maintained and entered, those scripts can read in that data and reproduce this analysis very quickly. So it shouldn't take very long at all to add any new data points to those graphs or to the statistics, and then hopefully it would just be someone to sit and interpret it and see what's actually changed.
Okay. Thank you, Sam, and thank you, Joan.
Great. Well, we're quite. I think we'll wrap up in the next couple of minutes. So we've got a couple more questions we can take. I've got one myself. I'm keen to ask about whether there are any I suppose game changer techniques out there that we haven't that we're not aware of, things like use of Earth observation data and wetness index as a means to get a sort of more global picture of what's going on the site, because obviously we're getting water level and vegetation data exactly where we've got the dip wells, but it doesn't necessarily tell you what's going on 10 meters away. I don't know if anyone's got any insights on that front.
I can probably provide some input to that, Robert, on the back of some other work we're doing for Natural England in Cornwall, actually, on some mires down there, where we're trialing actually the use of satellite imagery mainly, particularly to look at wetness. And it can be done in quite a simple visual way. It's the sort of thing, there's online web pages now where you can view the satellite imagery as it comes through, and looking at the different color bands, you can actually physically see areas that are wetter or drier at different times of year. So there's some interesting things there to look at landscape scale assessment. I think I do have somewhere an example we did for Fenn and Whixall. I think when Sam first started, I'll try and share it around for everybody. It's just a nice fun bit of analysis. But in terms of game changing, I think capturing on this water quality, one of the things that I've been working on with others in other communities is actually there's some incredible bits of kit now to look at things like nutrient concentrations, sort of little handheld devices that we've been testing with sort of lab data, and they compare really favorably. So if you are interested in developing an additional suite of, it can be as simple as you like, you can just do the outflow to start with, to capture some of that water quality data as part of your longer term community-led monitoring. I can definitely share some bits of tried and tested kit, Robert, that people might be interested in. But that's the big game changer for me, I think, that I've seen in the last 2 years or so. Just the ability to do lab level water quality testing for some of the nutrients we're all interested in in wetlands.
Oh, thanks. Thanks, Dave. Yeah.
Could I make one point about the volunteers, since a lot of people have asked about it, and I can see several volunteers on this call? It has probably an awful lot to do with sausages and beef burgers and chocolate biscuits and Christmas parties. And I mean this because I've got fingers in various countryside pies around here. And the only people who have successful volunteers over the last 30 years in general, apart from the National Trust, tend to be, they've been us at Fenn's, because we look after our volunteers. We've got Pete Bowyer on this call. In the Life Project, we've actually got a volunteer coordinator. We have social dues, there are newsletters, there are looking after your volunteers, and that keeps people coming. I don't know if Roger would agree, Sandra might agree as well, but it's very important because people can just feel used and then stop. And then we couldn't do it without them.
Yeah, great. Okay, one last question, and then I think we'll finish up. Any last questions?
I think there was one question around, and maybe Joan can answer this one, but in terms of getting a good, strong growth of new sphagnum in all these new wet areas that we're working on. I mean, how many decades are we talking about?
It's like having babies. It takes 9 months to get sphagnum. If you put the water back, there's so much spores flitting around in the air at Fenn and Whixall that you can get sphagnum in 9 months, which is what we found on those initial pictures. Remember, I talked about green sphagnum. It's greatly accelerated, obviously, if you can go flinging a bit of sphagnum around. And where we've got all of these cells with water in, which have been forest, I think it would help enormously if we were to go. And we've got big pools on the moss that peat cutters have dug that they grew bog moss in the past, like lettuces on a 3-year cycle. And we could go and do exactly the same, walking along the buns, chucking a bit of bog moss in. And we did this on one area of forest before, cleared forest, on Jeff Lloyd's forest. And it did make us get lots of forest in the bottom of the forestry plough. And that, we know it works. It's very expensive. We haven't got the money, Robert will tell you, to get any more Beda hummock or Beda gel You know that what you hear on the moors where they're planting lots of sphagnum, it's phenomenally expensive. But we have got our own that we could at least get. It's only Flexiosum and Cuspidatum, but we could get it going a bit more in the cells, a little bit more certainly, because it's a race between the bog moss and the Millennia.
Great. Okay, well, on that point, thank you for bearing with us for quite a long time. I hope you found the presentation interesting. Presentations. I want to thank Joan and Sam in particular for giving those presentations and pulling together all the data. I'd also like to thank Mags and Dave Gasker who helped us in finding Sam, who's done such a great job pulling the data together. And finally, I'd like to thank Sophie for arranging today, and just again say thank you to all the volunteers over the decades for pulling this data together. I think it's really good to hear other people's comments about what how rare it is to have such a good data set. So thank you again all for joining, and if you want to keep in contact with the project, either email the people who were involved today, or that we do have a project website, Meres and Mosses, and you'll find the Marches Mosses Bog Life project covered on that website. So again, thank you all for joining, and perhaps see you in a different guise some time or other. Okay, thanks.